So today's lesson is about a piece of the quadratic formula. There's a special part of the quadratic formula referred to as the discriminant. And so it does some things for us. It tells me about the types of solutions I'm going to have, okay? So let's say that. It tells me how many and the types of solutions a quadratic will have. A quadratic equation will have. So it's actually kind of nice because when they're really involved problems, I can quickly tell what this graph is doing. Is it crossing the x-axis twice? Is it only hitting the x-axis? Is it not even touching the x-axis? All right, so let's talk about the quadratic formula. At this point, you should know, I said that I really wanted you to memorize the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Hopefully you're hearing row, row, row your boat as you see that. Okay, so the discriminant is actually part of the quadratic formula. So do you see b squared minus 4ac? So going back, this part of the quadratic formula is the discriminant. So let's think about that. Do you notice that there's a plus and minus in front of it? Well, I'm going to start with b squared minus 4ac. If it were equal, if we plugged in all the values and we got it to be 0, meaning it equaled 0, well, that plus minus would go away, and that would give me one real solution. So if the discriminant actually reduces and simplifies to 0, then there will be one real solution. And that means actually one x-intercept. Okay, so one x-intercept. And the graph's going to look something like this. It's going to touch the x-axis like that. Okay? All right, now, going back, if this number was greater than 0, say it was like, I don't know, square root of 4, then you take the square root of 4, you do plus 2 and minus 2. So there would be two real answers, okay? So if b squared minus 4ac is greater than 0, then you would have two real solutions, or roots, and that would mean two x-intercepts. And so a graph of that is going to look like something like that. It's going to cross the x-axis twice, here and here. So here it crosses once. All right, and the last condition that can happen with this discriminant is that if b squared minus 4ac is less than 0, this means it's negative. Now, let's think about that for a second. That means that there is a negative number under the square root. And right now, you know that that can't possibly work because we haven't learned how to deal with that yet. What that actually means is that there are no real solutions. And I'm going to have you write this too, but it does mean there are two imaginary, yes, imaginary solutions. Not like your imaginary friend, though. Two imaginary solutions. So the graph is going to actually just not touch the x-axis. It's going to have a vertex that's either above or below the x-axis, and we'll talk more about that as we do it. Okay, so to recap, quadratic equations can have two, one, or no solutions, also x-intercepts. You can determine how many solutions a quadratic equation has before you solve it by using the discriminant. Okay? The discriminant is the expression under the radical. The radical is not part of the discriminant. So the discriminant is just b squared minus 4ac. Okay, so if b squared minus 4ac is less than 0, which means negative, then it will have two imaginary solutions. If b squared minus 4ac equals 0, then the equation has one real solution. And if b squared minus 4ac is greater than 0, then the equation has two real solutions. Okay, so let's look at an example. So your first example, oops, what is your first example? Where did it go? Okay, so sorry about that. All right, so first we're going to find the number of x-intercepts, which means we're going to use the discriminant. It just says determine whether the graph intersects the x-axis in 0, 1, or 2 points. So we don't have to do the whole quadratic formula just to understand that. All right, so we're going to use b squared minus 4ac, and we're going to see what happens to it. So I'm going to write down my a, which is 4, my b, which is negative 12, and my c, which is 9. I'm going to plug it into the quadratic formula. So negative 12, putting in parentheses, squared minus 4 times 9. All right, we simplify. So 12 squared is 144. 16 times 9 is, let's see, 16 times 9, I'm going to do it over here, is 144. Okay, right? 144, yeah. So 144 minus 4, 144 is 0. So b squared minus 4ac equals 0, which tells me that there's one real solution. Another trick with that is if it is a perfect square trinomial, then it will have only one real solution. Let me say that again. PSTs have one real solution, or one x-intercept. So I look at it. Is it a perfect square trinomial? Nice place to review here. 9 is a perfect square and positive. 4 is a perfect square and positive. Their square roots are 2 and 3, and the number in the middle is double that, which is double their product. So yes, it is a perfect square trinomial. Just a nice little thing for you to know. Okay, let's try the next one. One more as an example. Let me switch to green. So I'm going to write down my A, my B, and my C. So A is 3, B is negative 13, and C is negative 10. So I'm going to use the discriminant to find out how many x-intercepts or zeros that it has. So b squared minus 4ac. All right, I'm going to plug in negative 13. Be sure I'm putting it in parentheses so that I make sure I square that negative. And then 4 times 3 times negative 10. Okay, so 13 squared is 169. I've got a negative 4 times 3, which is negative 12. Negative 12 times negative 10 is actually plus 120. And that gives me 289. So it's a positive number. So b squared minus 4ac is actually greater than 0. That tells me that there are two real solutions, which means two x-intercepts. Okay? All right, so very short video today. I want you to take the time at this point to go back and read through your notes from the beginning. Make sure you feel comfortable with anything that we've done so far. Now, I know that I skipped a few pages of practice in between the quadratic formula and the discriminant. We're going to go back to those tomorrow in class when I get in so that we can review and make sure you guys understand how this all comes together. Okay? Have a great night.